The first thing I want to say is if we were to look at a graph, and I don't know if I'd bother quick drawing this, but say I have a graph, and we want to talk about a y-intercept. What do we know about that y-intercept? What has to be true about that point? Do you know x or y? You know x has to be what number? 0. That you don't know what height it is necessarily, unless somebody actually labels the axis. But you know the x value has to be 0. That's what makes it the y-intercept, that it's over, left, right, 0. It's just up or down a certain amount. So that's the first thing I want to say, is that the y-intercept is going to be 0, comma, and I'm just going to leave it blank. You could put a line in there if you wanted to, but 0, comma something for the y-intercept. We know the x value is 0, so if I would take that 0 and put it in here for my x and my x squared, and there for my x to the first, any number for a times 0 squared gives me 0. So that just becomes a 0. Any number times, so now for my b right there, any number times 0, so my x is 0, is 0. So you're going to have 0 plus c. So the y-intercept has to be whatever number is there at the end, right? And it could be like a negative something if you have your quadratic formula here ending in like a -6. Then the y-intercept has to be a -6. But y-intercept, you could say that this here is going to be 0, comma c if you wanted to. Or you could write y-intercept equals c. But that c is going to be that y-intercept. C is where it crosses y-axis. Good? Okay. I wouldn't write this next part, but I just felt guilty leaving it off the notes completely. This is kind of the old school, how the book recommends going through and graphing some random parabola, some random quadratic formula. And now I think it's easier just to type in your calculator where it says y equals, put in the equation, do the data table, and it'll spit out a ton of points for you. But if you have some y equals 5x squared minus 7x plus 2 or something like that, the first thing they want you to do is graph the y-intercept. Just put a dot where it crosses the y-axis. Then the next thing is find the vertex, and that's what we were working on yesterday. Does anyone remember the equation for finding the x value of the vertex? Nice. It's going to be negative b over 2a. So you could figure out, okay, for my vertex, that either very bottom point, vertex was the bottom of a parabola that opens up, or the top of a parabola that opens downward. So vertex is kind of like, we're talking this point right there. So we could find the x value using the b and the a. Once you know the x value, you could put that in right here, and then put that same x value into your equation, and then punch it in your calculator, find y, right? And then that'd be your y value. That'd be your y right there in your vertex. Okay, so once you have that, now they say find 2 points on the y-axis side of the vertex, and then draw in that half of the parabola. And then for a parabola, if it's drawn right, my number 5 there is I should have an axis of symmetry in a correctly drawn parabola, right? So if I found maybe my y-axis is over here, something like this. So if I find a couple more points over on this side of the vertex, now you see how I could take those points and just swing them directly across the parabola because it's symmetrical across that dotted line of symmetry. So you don't need to use the equation. You say, oh, this one here is 3 to the left and up 1. So then from your vertex you go 3 to the right and up 1. And so once you have that, the other points on the other side, you could draw them in. So I wasn't sure how much we really wanted to work through this, but if we wanted to do these steps, the y-intercept is going to be that number right there. Agreed? So I kind of went through and found my points first, and then that told me how to do the scale. So normally I'd go through and actually find a whole bunch of points before I put dots on there. But my y-intercept is going to be 0, 1, so this has to be up 5, so my y-intercept is going to be something right about there. Decent? I might be a little high. Then for my vertex, I could do that x equals negative b over 2a. So I have my b is a positive 4, so it'd give me a negative 4 over 2 times, this is my a value. Did I lose anybody with my ax squared plus bx plus c? Okay, so we're okay on where my b and a are coming from? Okay, so it'd be 2 times 2. So I just got a negative 1, so it's negative 4 over 4. So my x value is negative 1 for my vertex. Then if I took my negative 1 and put it in right here for x squared, put it in right there for x, so I have 2 times negative 1 squared plus 4 times a negative 1 plus 1. So I punched all that in. That's going to give me my y value for the vertex. Okay on that one? So I'd have left 1, so negative 1, and then down 1, so maybe right about there's my vertex. So I know my parabola now is going to be opening up kind of like this way, something kind of like that. Ooh, negative 1. I totally missed the scale. Negative 1. All right, so negative 1 is over here. That's going to look a lot nicer. So if negative 1 is there, my parabola is now opening kind of in that direction. Good? Now what the book is saying is go through and find some other points kind of on that side. So I could take my equation and put in different numbers for x. So I could put in, if I wanted to, x being like 1/2 and figure out where is it going to be there. I could put in like a positive 1. If I put in a positive 1 in my equation, that's going to give me a y value once I punch all that in my calculator of 7. So this one should be right about here. So I'm going to have to do some modifying on my parabola. So now I know it kind of goes there. I could put in a 2 for my x values and I get 17. So it's a little bit kind of shady to go above my 15, but so 217 is right about there. So I have this side of my parabola. Still good? And now you could go back and say, okay, starting at my vertex, I have 1 to the right and up 2 to get there. So then I could go 1 to the left, which gets me down to my negative 2, and up 2 gets me that right there. When I go 2 to the right, so 1, 2 to the right, I'm up at a height of 7. So now if I go 2 to the left, so 1, 2 down here to my negative 3, I'm going to be at a height of 7. So you kind of with me for drawing in this other side of the parabola? So that's kind of the book's long way. You saw it, yeah. Worth seeing, you think? I'll take that as I just totally zoned out. I don't know what I looked at. Okay, here's the part. Okay, for you though, when you get one like that, honestly, I don't even know what my equation is. So if I were to take that equation, y equals 2x squared plus 4x plus 1. I'd put it in your y equals on your calculator and then do second graph, get the data table, put some of those points on a graph, draw a smooth curve through them, put arrows on the ends. That's way better. All right.